Hi guys! Today I'm going to review some basic concepts of thermochemistry. Let's start with potential and kinetic energy. Potential energy is a stored energy due to its position and properties and force acting on it. Think of a roller coaster at the top, ready to move. That's potential energy. Kinetic energy is the energy in motion, depends on mass and speed. Think of the same roller coaster falling down. It works on kinetic energy as it moves. Let's take another example. Ball at height, potential energy due to position. Ball drops, turns into kinetic energy. When it bounces again, kinetic turns to potential energy. Isn't it interesting? Here's a small DIY experiment for fun. Enjoy it! Let's move on to exo and endothermic reactions. Hey, that's what we see. Exothermic is absorb heat, endothermic environment temperature rise, exothermic absorbs heat, endothermic react energy greater, exothermic product energy greater, endothermic calorie giving heat, exothermic plant making food, endothermic. Let's get into serious business and look at a graph. Now let's move on to an endothermic and an exothermic reaction pathway. An exothermic reaction is when the reactants have a higher energy than the products. In an endothermic reaction, products have a higher energy than the reactants. Here, energy is being released. Here, energy is being absorbed. The highest point is called the activation energy. This is the amount of energy needed for the reaction to occur. At this point, the reactants are in a temporarily unstable phase. That's called the transition state. Heating curve. Solid to liquid, add heat. Melting point. Think about ice cream melting or snow melting in the sunlight. Liquid to gas, add lot more heat. Boiling point. Think of water to water vapor or gas in Carter fumes. At melting point and melting and boiling point, temperature remains constant till then slope increases. Cooling curve. Slope and temperature decreases with time. Gas to liquid. Gas to liquid removes heat condensation. Think of CO2 in the phase or water vapor forming dew. Liquid to solid remove more heat, freezing point. Rain to snow is a good example. Wax hardened candles is another. Again, here at condensing and freezing point, constant temperature. During the process, temperature keeps going down. Phase change. Phase change diagram shows how a substance changes between solid, liquid, and gas. Phase depending on temperature and pressure. These are phase boundaries. These boundaries represent condition where two phases exist together. So an example of the solid is melting and freezing, solid to liquid is melting and freezing, liquid to gas is boiling and condensation. Low temperature and high pressure, solid phase. If temperature increasing or pressure decreases, liquid phase. If keep increasing temperature or decreasing pressure, further gas phase. The critical point is located between the solid and gas boundary. At this point, distinction between liquid and gas disappears. The substance becomes supercritical fluid. Have you ever thought why an empty pot's temperature rises quickly? If you put water and heat, it takes a while for a temperature rise. Why? Specific heat of water is greater than specific heat of air. For example, if you go to a beach, you see that sand heats up and cools down much faster than water because sand has a lower specific heat capacity. Specific heat formula is Q equals the mass into specific heat into delta T. Q stands for energy required, mass is grams, C is specific heat, and delta T is the change in temperature. An example problem. You have given is 8 grams of gold, which is heated from 75 degrees Celsius to 95 degrees Celsius. They ask how much energy was used to heat gold. Your specific heat capacity of gold is 0.109 calories per gram Celsius. So M is 8 grams, 0.109 is specific heat, and delta T, which is final minus initial, which is 95 minus 75, which is 20. Then I multiply 8 into 0.109 into 20, which is, and your answer is 20.664 calories. This is the last topic that is covered in thermochemistry. Hope you like this video. Bye guys!